the first to the last of it, delivery is passionate, the whole and not the half of it, forecasting aftermath of it, projectile and I'm blasted with.
Hello everyone, it's your old friend Mr. Los. Welcome to another edition of HL Chemistry Flipped Classroom. Today we're going to be talking about the basics of chemical reactions, how to interpret them, how to balance them. So with no further ado, first of all, it's obviously really important, this is a chemistry class, it's obviously really important to be able to correctly interpret a chemical reaction. So let's make sure that we're doing that. We have our reactants. Reactants are written on the left, always, 100% of the time. You have those big numbers in front, those are called coefficients. You have these little numbers right here, those are called subscripts, and they mean different things. And in a second, we're going to make sure that we understand the difference between those. On the right side of the reaction arrow, always, are the products. So here, we have this chemical reaction where sodium plus chlorine is making good old table salt. So this represents a transformation. This is a way of representing in writing something that occurs, in the real world. So you need to think about this as this transformation that's taking place. And we have a before here on this side, and we have an after on this side. I showed you this chemical reaction in another video. I'm going to link to it again. Hopefully that should pop up on the screen here. Just watch it again and imagine that thing that you see taking place in that video with a big flash of light. That's the same thing. This is just the representation of that on paper. And I think a lot of the problems from chemistry stem with people not imagining chemical reactions correctly. So we're going to definitely spend some time making sure we're wrapping our brains around this right. Also, I said this already, but keep in mind, reactants or the reactant is always on the left no matter what. So like in this reaction right here, sometimes some people will see that and they'll somehow think it's different, but this is the reactant. In this case, there's only one reactant, and these are the products over here. So on the left, by definition, always are the reactants, and products are on the right. By the way, as you're going through these, if you need to pause to take these notes and make sure that you get stuff written down, please do that. I'm just going to kind of move through them, but pause, go back, do whatever you need to do to help yourself get these written down and or understand the material. So subscripts, like I said, those indicate items that are chemically bonded. Basically, if things are written right next to each other like that, it means they're chemically bonded together, or a subscript indicates there's two of the same thing chemically bonded together in this case. Coefficients indicate how many particles of the atom or compound are present. So just to show you a kind of picture here to illustrate the difference between these things. Again, super critical that you're imagining these things properly and thinking about them properly, or it's going to cause you all kinds of problems in chemistry. Cl2, if these little blue things are chlorine atoms, and that's a bond between them, like we talked about in the last unit. Can you say what type of bond it is? Hopefully you can say that that's a covalent bond. But anyway, Cl2, we could imagine it like that. Whereas 2Cl-, two chlorides, that's something totally different. That's two separate chlorides that are not chemically bonded together. We could also have 3Cl2, so that means 3 of this little Cl2 thing. So there's 3 of those. Notice that the whole thing is not chemically bonded. There are 3 separate Cl2s. So, to some people this is obvious, others it's a little more difficult, but again, a bunch of chemistry really requires that you're imagining this and thinking about it properly. Another thing we've got to keep in mind is that equations must be balanced, and I know a lot of you have probably done balancing in other science classes in the past. I hope you have, but we're going to review it here just to make sure that we understand. So here we have this reaction, hydrogen plus oxygen gas makes water. Now this is very much like that sodium and chlorine one. This is a very exothermic, explosive reaction when this happens. But, if we think about the law of conservation of mass, we might notice that there's a problem here. There's 2 hydrogen atoms, 2 oxygen atoms, but over here it seems as if an oxygen atom has disappeared, because there's 2 on this side and there's 1 on this side. So, what we do to fix that, what we do to balance things, is put coefficients in front. So if I put a coefficient 2, now what that represents is there's 2 H2Os. Now our oxygen problem is fixed. Remember, reactants, products. This is the before, this is the after. matter cannot be created or destroyed. So now our oxygen situation is fixed. There's 2 oxygens on this side, there's 2 oxygens on that side. The problem is, now there's 4 hydrogens. 1, 2, 3, 4, because there's 2 H2Os. So to fix that, I'm going to put a 2 there, and then we've balanced this particular equation. The hydrogens are balanced. There's 4 on both sides. 1, 2, 3, 4, 1, 2, 3, 4, 2 oxygens, and we're good to go. So we're going to spend the rest of this video doing a bit more practicing with balancing. For some people, balancing is super easy, and for others it's more difficult. Certainly some reactions are easier to balance than others. Some are very, very difficult to balance for anybody. But we're going to practice a bit with balancing reactions. Now if you see it and you got it and you know how to balance reactions, just go ahead, do your thing, and balance those reactions. Those of you who are having a little bit more trouble, you know, watch the video carefully, even watch it a couple times if you need to. But we're going to go through one of the pages in your workbook. We're going to practice a few of them, and I'm going to give some hints and tips for balancing. Okay guys, so we're going to be looking at this. This is a page from your workbook. It says Balancing Chemical Equations 1 at the top. It's probably the first page in the reaction section. We're going to look at a few of these. I'm going to do about 4 examples or so. And like I said, you know, if balancing, if you already know how to do it, if you're good with it, just do your thing. Just balance these reactions. All that's important is that by the end of this video you know how to balance reactions. If not, you know, take your time going through with me and looking at these examples. I've taken a few of these and I've kind of blown them up here a little bit so that we can see a little bit better. So let's start off right here with number 1. So when we look at this reaction, we see what we're looking at is on both sides of the arrow, there's 2 nitrogens here and 1 nitrogen here, so the nitrogen's not balanced. There's 2 hydrogens here and there's 3 hydrogens here. So nothing is in balance here and we've got to fix it. In some ways, balancing chemical reactions is like a little puzzle. There's really not much I can tell you about how to do it. There are a few tips of the trade that we can kind of go through that I'll tell you about as we go, some little hints and tips, but other than that, you kind of just got to work at it and figure it out. When you're first starting, if you want, you can do something like this. You can list all the elements that are in the equation. So here, we just have nitrogen, hydrogen, there's nothing else. And go like this. And so let's count. On the left side, there's 2 nitrogens, and on the right side there's 1. On the left side there's 2 hydrogens, and on the right side there's 3. So we got to try to fix it. Let's start with the nitrogens. There's not enough nitrogens on the right, so to remedy that problem, I put a 2 in front of the nitrogen, of the NH3 rather, that's ammonia. So let's think about what that changes. Now, instead of 2 nitrogens, instead of 1 nitrogen, there's now 2, but also, remember this 2 applies to both of these things here, so now there's 2 times 3, now there's 6 hydrogens. So the nitrogens are balanced, there's 2 on both sides, but the hydrogen is not. On the left side, we still have 2 hydrogens, but on the right side we have 6, so I have to fix that, and I can do that by putting a 3 here, because 3 times 2 is 6. And so now that equation is balanced, but always go back and double check. 2 nitrogens here, 2 nitrogens here, 3 times 2, 6 hydrogens here, 2 times 3, 6 hydrogens here, so that one's balanced, and we're good to go. Let's take a look at another example. So this is a decomposition reaction. Again, this is still the reactants on this side, this is the products on this side. This time we got 3 different things. We got potassium, we got chlorine, and we got oxygen. By the way, this thing I'm doing here, making these, if you can balance equations without doing this, by all means do it. I'm sure, hopefully most of us will in fact learn to balance without doing this. Like I personally would never do this if I was balancing an equation, but it's just something we can do at first to kind of get our bearings and kind of like training wheels, I guess. But do whatever works for you. I don't care. Draw pictures, anything, as long as you get it balanced. So looking at this, there's 1 potassium, 1 chlorine. Remember this 3 only applies to the oxygen here. 1 chlorine, 1 chlorine. It's really only the oxygens that are, let me go ahead and write that in. It's really only the oxygens that are out of balance at this point. We've got 3 oxygens here, and we've got 2 oxygens on this side. So I would balance the oxygens. It's almost like finding a least common denominator type thing. The way I can get these oxygens to the same number is if I have 6 of them. So if I put a 3 in front of that, 3 times 2 is 6. That makes a 6 there. But then to fix my oxygens on this side, I put a 2. That makes 6 oxygens. But then I need to keep in mind also that changes my number of potassiums, and that changes my number of chlorines. So now my oxygens are balanced, but by putting that 2 in front of that, I've changed my potassium and my chlorine. But no worries, we can fix that easy enough by putting a 2 here. So now everything is balanced. 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines, 6 oxygens, 6 oxygens, and we're good to go. Sorry, that was crooked. Alright, so this brings me to one of my first real tips for balancing. What I would say is, if you notice polyatomic ions, this is one of the many reasons it's important to know your polyatomic ions. Like I'm seeing sulfate here. If you can, it's a good idea to balance polyatomic ions as a whole. In other words, rather than thinking about this as 1 sulfur and 4 oxygens, which it is, sorry my dog is getting upset, just think about it as 1 sulfate. And rather than thinking about this as 3 sulfurs and 12 oxygens, which that's exactly what it is, but it's easier just to think about it as 3 sulfates. So in this one, aluminum, bromine, potassium, and again, I'm just going to think about the sulfate as a whole rather than trying to balance that oxygen and sulfur individually. I mean, you can do that if you want, it's just easier. So think of polyatomic ions as a whole, that's one tip, and also balance them first. What I mean by that is I could possibly start by trying to balance these potassiums because the potassiums are out of balance, but it's probably a good idea. So we've got 1 aluminum, 2 aluminums on this side, 2 potassiums, 1 potassium on this side, bromine, we got 3 bromines, 1 bromine, sulfate, 1 sulfate, 3 sulfates. This parentheses here, the 3 is distributed only to the sulfate here, so we got 3 sulfates on that side. So basically nothing is in balance, and I could choose to start in any one of these spots, but your best bet usually is going to be to start with a polyatomic ion. So I got 3 sulfates on this side and 1 sulfate on this side. I'm going to put a 3 here, so that's going to fix my sulfates. So now I got a 3 on that side. That also changes my potassium. 3 times 2 is 6. So now there's 6 potassiums on that side. So then we could go and try to fix some other stuff. And again, you know, kind of jump anywhere here. Well, there's 6 potassiums now, so I need to put a 6 over here. Now that changes to 6 potassiums on that side, and that also changes my bromine to 6. Now fix the bromines. Bromines are out of balance. 6 on this side, 3 on this side. Put a 2 there. That makes 6. And lo and behold, that also fixes my aluminum. And there we go. Everything is in balance. And we can move on to the next one. One thing I will say, I guess, is sometimes in one like this, you'll get a little crazy, and maybe you end up getting something like this. 4, 6, 12, 2, let's say. That would indeed be balanced. If you looked at it, it would be balanced and it would work, but you always need to balance things in the lowest possible terms. So if you ever get a situation like this where you could divide every single one of them by the same number, so in this case we could divide every single one of them by 2, you should reduce it, if possible. Okay, number 8. The other tip I have, besides balancing polyatomic ions, is sometimes notice when there's elements by themselves, you want to save that for last. You want to balance oxygens last. The reason for that is we could start at any place, but if we balance oxygens for last, we can put a number in front of this oxygen without screwing other stuff up. And that's what will be frustrating when you're balancing sometimes, is you'll put a number in front of something and it'll throw something else off. Well, if we save oxygens for last, we can put a number in front of this and not throw anything else off. So that's one thing to keep in mind. So I'm going to go ahead and skip using these for this one, just so you can see kind of how the thought process can work without that. I'm going to start with the carbons. There's 3 carbons on this side, so I'm going to put a 3 there. So now I've balanced my carbons. There is 8 hydrogens rather on this side, so I'm going to put a 4 there. So now I have my hydrogens and my carbons balanced. Well, now we need to balance the oxygens last. Now keep in mind, what sometimes people forget is what the total number of oxygens is on this side now. There's 3 times 2, there's 12 oxygens here. And we need to not forget these 4 plus another 4. So there's 16 oxygens on this side. Wait. Scratch that. Math is not always my strong suit. 3 times 2, 6 oxygens on this side, plus another 4. So that makes 10 oxygens on this side. Well, since there's 10 oxygens on this side, if we put a 5 here, that's going to make 5 times 2, 10 oxygens on that side. So now that thing's balanced. 3 times 2 is 6 oxygens plus another 4, that's 10. So that's it. That's all the examples that I'm going to show for now. What you should do is go back through that page. You should try to balance all those. Some things are easier to balance than others. Some of them might already balanced. The last tip that I would have that we haven't got to yet, if you find yourself in some trouble, try multiplying by 2. What I mean by that is sometimes, like for example, this one number 9 here on this page. This is probably one of the trickier ones to balance on this page. If you find yourself being frustrated and things aren't working, maybe start again and consider like putting a 2 here, for instance. Just try that out, see how it goes for you, and if you have questions, we'll definitely go over these and talk about them next class. Thanks, and good luck balancing.